Hi gang, it's time for another exciting pre-calculus lesson, this one on 10-3, ellipses. Here you can see kind of a nice pictorial of what ellipses are all about. These two focal points, F1 and F right here, if we add up the distances to any point on the plane, that distance will always be constant. So that's kind of a good way to remember about those. The traditional definition of an ellipse is you could take a couple pins and put them on a piece of cardboard and put a string between them so it's kind of loose. Pull your pencil so it pulls that string tight, and then just keep pulling that tight all the way around, and sure enough it would produce an ellipse. And the key thing is the distance of these two segments will always be the same no matter what point you're on the ellipse. There's a little website there that we might look at in class that will show this animation a little bit better. Now this is a good thing for you to pause and write down. This is some of the key features of an ellipse. We have the major axis. That's always the longer one. In this case it's going to be the horizontal one. We have vertices on each side, so there's a vertex here and here on the major axis. We say that the major axis, or these vertex points, are A units from the center. So the center being here, A to here, and also A to there. Therefore, that major axis is 2A units long. The minor axis, in this case anyway, would be the vertical one. It's always the shorter of the two axes, still has those vertex points at the edges like that. And here, the minor axis, the vertex points are B units from the center, thus the whole minor axis is 2B units in length. And here's our focal points right here, represented by those C's. They're always C units from the center. So this is a nice diagram for you to down. With ellipses, you got to know your ABCs, and the relationship between them is designated by this little formula right here. C squared equals A squared minus B squared. Very, very important. We'll see how that works here pretty soon. Here's another picture and format of standard form ellipse equations. You can see they look pretty similar to how they did circle-wise with the x minus h's and y minus k's. Keep in mind that that major axis is represented with A and the minor with B. So when we have a horizontal orientated ellipse like this, where the longer axis is horizontal, notice that the A squared is underneath the x term. On the other hand, over here, when we have the vertical orientated ellipse, notice that the A squared is underneath the y term. So that's kind of a key thing. And notice the difference between this and the circles is that we like to have these equal 1. So this is the standard form that we'll be trying to get ellipses in this lesson. Alright, here's the general form for elliptical equations. Notice that looks fairly similar to the general form we used for circles. The big difference, though, that you see is right here. With circles, the A and the C, they would have been the same. But with ellipses, as you can see, likely these are two different numbers. Alright, we're going to actually try doing some of these here now. And so we'd like to try to graph this ellipse and then try to pick out some of the key points. As you can see, this is an ellipse that is in standard form, and we can tell which is going to be the major axis. The bigger number here is 36. It's under the x term, so the x-axis is going to be the longer one, so it's going to have an orientation horizontally here. What we look for here is the center, and the center, of course, is designated by those numerator up there. In this case, our center is going to be -3, 2. And we can plot that on here. I'm still trying to get the hang of being able to get that dot on there. Very good. I missed a bit, but that's okay. Now, how we graph this is I look at the major axis first of all. I notice that that's a 36 there. And if you remember back to the other slides, that's actually A squared. So if 36 is A squared, that means that the A value that I'm interested in must be 6. So I count 6 units away from that. So 6 going to the right will take me to positive 3, and 6 units to the left will take me to negative 9. That's my major axis right along there. My other axis, I'm going to get a different color here for you. My other axis here, the minor axis, that's going to be b squared. So if 4 equals b squared, of course that means that b will be 2. And so now I count up 2 and down 2 for the minor axis there. And that enables me now to draw my entire ellipse here, which should look something like this. Now we know the center then is at that point there. The vertices are going to be way at the end here. Notice that there are actually 4 vertices. There, and there. I'm not going to take the time to point those out. But what about the equations of the foci? That's kind of a key thing that we want to try to figure out here. And remember that key relationship. It was c squared equals a squared minus b squared. That's knowing your ABCs with these ellipses. C squared is what I'm looking for. I know that a squared was 36 and b squared was 4. So that means that my c squared is going to be 32, and c then will be the square root of 32, which is somewhere between 5 and 6. So if I'm going to actually try to plot my focal points, they're going to be pretty far over here. Again, the focal points are always on that major axis, and so they're going to be way over there about in these particular points. And in class we'll talk more about trying to figure out the actual coordinates of those buggers. Next slide, notice this is in that general form. Can we actually get this now in standard form? And so let's see what we can do with this. You probably guessed we're going to do a little completing the square here, so let's try that. I'm going to try to group all of my x's together here. So I have my x's looking like that, and then here's my y's. I'm going to try to group them together, and that's going to equal the 116. Now, what's different about completing the square here is that we have these big coefficients here in front of the x squared and the y squared, so that's going to goof us up a little bit. So what I'm going to do is actually factor out some stuff. I'm going to factor out a 25 from this. So that leaves me with that. Here I'm going to factor out a 9. That leaves me with this. And now I'm going to complete the square like I've done before. And again, I'm going to focus just on what's inside here. So if I complete the square on this, I notice that half of that negative 4 is negative 2. I square that so I can add 4 right there. And over here with my y's, half of negative 2 is negative 1. Negative 1 squared is plus 1. So I'm going to add that. And then here's where the tricky part comes in. It looks like I should maybe just be adding 5 to each side, 4 here and 1 here. But that's not true because I'm still multiplying that expression by 25 and 9. So here's kind of a tricky part here. What I'm going to really add to each side now is I'm going to add 100. That's 25 times 4. And 9. That's 9 times 1. So what I'm going to really end up with here then is I have 25. I'm going to complete the square here. That's going to be x, excuse me, that 2 shouldn't be there, but it should be x minus 2 squared. Boo-boo right there. Plus 9 times y minus 1 squared. All this is going to equal, when I add these up on the right, I believe 225. If you remember though, we like to get that ellipse equal to 1, so I'm going to divide everything by 225, like this. And so in standard form then, I'm going to end up with x minus 2 squared over 9. 25 goes into 225 9 times, plus y minus 1 squared over 25, because 9 goes into 225 that many times, and that's going to equal 1. So there you see I can pick out my center, which in this case is going to be, I think actually this should be a plus sign in here, shouldn't it? I kind of goofed up along the way there. So I think it should be negative 2, 1. There's going to be my center right there. And this time notice that my bigger number is underneath the y term, so that's going to be my major axis. I'm going to count up 5, which will take me to about here, and down 5, which will take me to about there. And on my x-coordinate, I'm going to count over 3 each way. So that's going to get my ellipse to look something like that. And we could come up with the coordinates of the foci and the vertices, but I'm not going to take the time to do that now. Finally, our last slide, there's Jerry right there. He was kind enough to get all dressed up and go play a little pool for us. He went all the way over to New York to do this. Here's an example of this elliptical pool table, and notice that right there, there's one of those focal points. There's only one pocket in this pool table. So thanks to Jerry for getting all dressed up and doing that for us. All right, sounds good. Hopefully you get some good notes, and we'll see you guys all in class tomorrow. Bye now.